Okay, welcome back. We're going to do something similar to the previous video, but we're going to be looking at frequency and probability distributions. So a probability distribution or a probability density function is really a graph of the number of occurrences of particular words or particular variables, not necessarily over time, but just the frequency with which they occur. Do you want to say something about that, Mike?
Yeah, I mean, what this is doing is it's going to calculate the frequency distribution of the entire corpus, and it's going to give us a way to do a very similar analysis what we've done before to do the MLE, but it's going to be using some features that are provided by the NLTK toolkit to make our lives a little bit easier and a little bit more detailed.
Okay, but let's be clear about this. What it's going to show us is the occurrence of a particular word, and we're going to see inside the data set, we're going to see the word and we're going to see the number of times it occurs.
Yeah.
But we're going to see that for lots of different words, whereas previously we were just looking at one word and seeing the percentage of time that happened.
Yeah. So I'm going to modify, I'm still using the same script that we used for Lab 1. So we already had RE imported, so we don't need to re-import that. So I'm just going to modify this second sentence here. So we're looking for, rather than wording and then using a variable that holds the tokens that have already been tokenized, we're going to actually tokenize it ourselves. So what we do want to be looking at here is where my centers come from. That's quite interesting, John. We're using a variable there that has not
well,
actually...
You've got my cent at the beginning there, but
that's again, a different variable, so we're actually tokenizing something called my cent. Where did we find my cent from? To learn in this lab, where did we get my cent from?
Okay, let's have a look what my cent is.
Yeah, it's, let me just write this in. What did we do? My cents. So we were going to use a variable called my cent, and we're going to search for the word. So what I'm going to, I mean, that's going to give me an error now because we haven't seen my cent. My cent does not exist.
Yeah.
So what are we doing with my cent?
Well,
we've got the cat sat on the mat. So this must have been from the previous.
Yes. So we need to create my cent. We need to create it, which is the same as this.
Yes, the cat sat on the mat, and it was a capital. So we'll just quickly create that. My cent equals, we open our speech marks, the cat sat on the mat, full stop.
Okay. Remember that from the first session that we did.
Okay.
Now we shouldn't get the error when we run this.
Now we can, yes.
Okay, that's gone through fine.
Great. So now we have my cent tokens no punct. Let's have a look at what that variable now holds.
Okay.
Cat sat on the
That's a list of the words, which is good.
Yeah.
So now we've taken a sentence. Let's be clear about what we've done now. We've taken a sentence, we've converted to lowercase, we've tokenized it.
And moved to the punctuations using the regular expression.
Yep. So now we've got a list of the words which are in there. Now what we want to do in the next bit is we want to, from NLTK, import frequency distribution, which is going to do some magic for us as far as the numbers are concerned. And my cent frequency distribution and the rest of that, so frequency distribution my cent.tokens no punct. So we're calling a function inside NLTK frequency distribution, and then finally if we show frequency distribution, sorry, my cent fdist, that's the one we want. We now display that. Look at that.
So we have
the occurred twice. Is that correct?
Twice,
yes, that's correct.
Yep.
Look at that. Look at that.
So we can verify the result is what we expect, and it certainly does that. Number of items in the frequency distribution must be equal to the number of words, types, and each type is associated with the occurrence count. As we can see, we have the occurrence count and the type. The occurrence count and the type. As you can see, there has only appeared once, whereas we have it actually 2 times in a sentence. So it's created that frequency distribution list that we need.
Okay, so that's it says frequency provides methods that allow to access these counts. For example, you can query the most frequent two words by, so let's do that. So mycent fdist dot most common.
What do we do there? So we need to actually enter in there how many. We had a query for an argument of that.
Yeah.
And so if I open the brackets, it's saying n equals none. List the n most common elements. So we want to see.
So we want to see the
first
two most common. Yeah. Look at that. Okay, smart. So and so. Do that for Monty Python and show me the top 5 words in the Monty Python list. Do you reckon you can do that?
Yep, we can quickly do that. So let's start right back from beginning here again. So we need to tokenize Monty Python. We've already done that.
Yeah.
We've got that in n tokens,
Okay.
no punct. So what we can do is
So that's already contained in memory for us.
yeah, we can do now. We can do an MP fdist to represent Monty Python
Frequency distribution. Yep.
equals fdist of, and now
we wouldn't
choose
want to print this, would we? Because it would be
Wouldn't
very
want
large
to,
and it would fill up the buffer and probably crash the Python window, wouldn't it?
Yep. So we'll put our no punct in there like so.
Okay.
Now I have that
quite fast,
option
too.
there. Now let's jump straight in to find the 5 most common
Yeah,
words.
5
Yeah.
most
Does that
common
sound
words,
like a
yeah.
good?
Because it's going to print out nice and neat, I would hope.
So I'm going to use this variable here, and I'm going to use the dot most common method because it's now an object, isn't it? We want to look at the 5 most
Top
common
5,
words. The, you, Arthur, I, and they.
Look at that! Isn't that amazing? Go on, then do that for the top 10. Let's have a look at the top 10.
Top 10, we'll copy that easily done. We can copy that in and see what the top 10
You
is.
see how powerful this code is now, don't you?
So they're all just the ands, ofs, tos,
Yeah, okay.
s, and it.
Now I guess there's ways that, well, we'll come to that later, I suspect, but there's ways in which we can take out things like the,
Yeah.
it.
I mean, this s, for example, will probably have come from an apostrophe, and the
Yeah.
apostrophe's been removed. And now, so that it's treating s as a word. So lemonization and stemming would be able to possibly take away
Yeah, you
that
took a question about that in the lecture I was in, didn't you?
Yeah.
Around that? Okay, that's good.
Okay, so the last thing to look at here is the most likely estimate probability distribution. So we're going to import another,
Hang on, what does that mean?
this one here, we're looking
Yeah,
at
what
the
does that mean?
probability distribution of a most likely estimate. And we're going to be looking at that from our,
Yeah, but explain most likely estimate to me.
the most likely estimate is the simplest form of probability, like you would calculate the odds of a coin flip.
Okay,
Yeah?
okay, yep.
So it's this.
Rather than dividing down by the number of words
Exactly.
like we did before. Okay, I understand.
Okay, so we will start by importing from NLTK the new function, which is MLE popdist. From import.
Yep, so another library coming from NLTK. That's a powerful library, isn't it?
Oh yeah, it's very big as well. MLE popdist.
Which is why we're importing modules from it,
Yes.
rather than from NLTK import star,
Did I
right?
spell that wrong?
typo.
MLE.
But we could do from NLTK import star, and we'd import tons and tons of stuff in that we don't necessarily need to use.
Okay, so we are. What have I done wrong here? Prob, not prod. Prob.
Prob,
dist.
yeah.
Okay.
Simple typo.
So then we'll say mycent pdist equals MLE prob dist mycent frequency distribution. Yep. Okay, I've got another typo here. Mycent pdist is MLE prob dist mycent.
There we go.
So, name mycent fdist is not defined, so I've spelled this wrong, so we'll just quickly look back up to where I defined the distribution. mcentfdist. mcentfdist. So it's a simple typo problem again. mcentfdist. There we go.
There we go. So happy with that.
Okay, so now let's print mycentpdist. We print that out, and we have a probability distribution based on 6 samples.
Okay.
So to print the probability distribution, we have to use the following statement. So
we've got to cycle through them, and
We're gonna have to
effectively a
cycle.
for loop, yeah.
So we're using the variable with x, and we're doing mycent prob. So we take this variable here.
Okay, speak up, Mike. We can't hear you.
Just typing this in from the lab script. So we're going to look at the prob of x. So we're going to loop through x. We create a variable with x, and we're going to loop through all the 6 samples, and x is going to represent the sample index.
Okay.
Yeah.
Yeah.
So look here, I've got my for loop for x in mycentpdist samples. So samples obviously holds the count of the number of samples that are currently available. So let's have a quick look at this before we execute it. So we're saying create a variable called x, and x I want to go from 0 to the amount of samples that are available in my sample, which is 6. And
That's
for
the
each
in
one,
part,
this is the looping part, and then the actual bit, this is what's going to be executed on every loop iteration.
Yeah.
And we're going to say that I want to print this pdist probability.
Okay.
Yeah?
Yeah.
And there we have it. So we have the as a 0.333, cat as a 0.16666, sat 0.16666, and you can see that that's the case, because when we look back here, we see that we have the twice and cat only once.
Yeah.
Yeah. So the probability is twice as high.
Yeah.
Yeah. So that's worked out absolutely perfectly.
And we could obviously do that as before with the Python script Moby Dick or War and Peace if we wanted to.
You could. You could. Now this shows you a couple of very powerful functions available within the library, and you can refer to the NLTK API documentation to explore some of the other powerful features available in that library, and to make your tasks, assignments and future projects much simpler.
Fantastic.